Hello everyone, I'm James and welcome to episode 8 of the OpenGL tutorial series. Today we're going to refactor our code one more time, otherwise we'll end up with spaghetti carbonara. Let's begin.
What we really need to refactor is how we manage our scene. I started by creating a scene class in a header with the same name. We'll add a constructor with the window as the parameter. Make sure to include window.hpp. We'll also add an update method, which will take the delta as a parameter. This is basically the frame time. Finally, we'll add a render method, which will take in a reference to the window as a parameter. Now let us implement the scene constructor. I'm going to grab all the initialization code from the main file and move it to the scene constructor. We'll make the cube, the transformation, the camera and the shader fields of the scene class. Make sure to include the necessary header files. Now we'll remove the variables we don't need anymore. Make sure to import texture. Now let's implement the update method. I'll grab the update code from the main file and move it to the update method. I'll replace frametime with delta. I'll make the x variable a field and I'll initialize it to 0 in the constructor. Now we'll implement the render method. I'll grab the render code from the main file and move it to the scene's render method. In the main file we can remove the x variable and create a scene. This takes the window as a parameter. Make sure to include scene. Right after we process events, we'll call scene.update, passing in frametime as the delta. Before we swap the buffers, we'll call scene.render, passing in the window as an argument.
Okay, I made a couple of mistakes. This texture should be a field, otherwise it will get destroyed once the constructor ends. So texture is going to be a field. Also, we need to include texture in the header instead. Now instead of creating a new texture variable, I will directly initialize the field. And now if we run, there we go, we get the exact same result. Awesome.
Now it's time to make a very simple entity system. So I'll create an entity class. This will have 3 fields. The first field is a transformation and will include transformation.hpp. The second field is a shared pointer to a mesh. We'll need to include mesh.hpp and memory. The third and final field is a shared pointer to a material, which we still need to define. Now we'll add a render method to the entity. This will take in some parameters. The first parameter is going to be the view projection matrix of the camera. The second parameter is going to be a boolean, which will tell whether we want to render the inside or the outside of the mesh. This will be useful when we add a skybox. If render inside is true, we'll tell OpenGL to cull the front faces. Otherwise, we cull the back faces as we're currently doing. Next, we'll get the materials shader. We'll add this functionality soon. We'll also need to include shader.hpp. Next, we'll bind the shader and set the UWVP uniform. Before we draw the mesh, we'll call a method of the material which we haven't defined yet. This will be called update uniforms. Finally, we'll call the mesh's draw method. Now we'll create a material class. This is going to be the base class for all materials. The only fields this will have is a shader. We'll obviously need to include memory and shader. I'll add a simple constructor that will initialize the field. Now we'll create a new class which is going to inherit from the material class. I called it basic material. This class will have one field which is going to be the texture. And we'll obviously need to include texture. The constructor will take in a texture and will initialize the shader to the basic shader. I almost forgot to add the update uniforms method in the base class, so I'll do that right now. I mark the method as virtual because we are going to override it. In the basic material class, we'll override the update uniforms method. Inside the method, we'll first bind the texture in slot 0. Then we'll send 0 as the uniform for the texture. Back in entity.hpp, we'll include material.hpp. In the scene header file, I'll remove these fields. Instead, we'll add a vector of pointers to entities. We'll need to include entity.hpp. I'll add a helper method which will create an entity and store it in the vector of entities. In the scene source file, we'll create an entity. For the first parameter, we'll pass a default transformation. For the second parameter, we'll pass mesh create cube. And for the final parameter, we'll pass a new basic material with the bricks texture. Now we'll remove all this unnecessary code. In the render method, we'll remove everything except for the clearing of the screen. Next, we'll store the camera view projection in a variable. And finally, we'll loop through every entity and render it.
So I commented out this code that doesn't work right now. And if we run, we get the cube. It's completely static because I removed that effect. To bring it back, we'll need to store a field for the entity. So I'll create another shared pointer entity. It's going to be a field. I'll call it entity. And in scene.cpp I'll set entity to the result of create entity. And now here we'll do entity dot transformation and entity dot transformation. Actually it's arrow transformation because it's a shared pointer. And now overrun. There you go, the exact same result. Awesome. I added a bunch of cubes, 100 in fact, and I've put them in random locations. If I run now, look at that. We have a bunch of cubes and they're all rotating. I actually didn't show you the rotation code, sorry about that. So this is the rotation code. It's exactly the same, however I'm doing it for every single entity. There you go. And that, my friends, is the end of this video. In the next video we are going to start lighting. I'm really excited for that. If you want to be notified when the next video is coming out, please consider subscribing to the channel and hitting the notification bell. With that, thanks for watching and goodbye.